Hey guys, welcome to Great Learning. Now, as you can see, Scikit-Learn is actually a super popular library which helps us to do a lot of machine learning tasks in Python. Now, when you see Scikit-Learn and when you see Python in the same sentence, you have to understand we're talking about the best of the best, the cream of the cream here, right? Firstly, coming to Python, you will already know that Python is one of the top programming languages in today's world and it has its own reasons, right? We can discuss for hours and hours about the greatness of Python. Shift your attention slightly towards Scikit-Learn. Now, Scikit-Learn, if you may or may not know it, is an amazing library or really powerful library that let you simplify extremely complex machine learning tasks, right? Now, if any of you all who are new into machine learning, you're watching this course here at Great Learning, you might think of a fact that saying, hey, machine learning is very complex. Maybe implementing machine learning using a lot of Python code will eventually be a ton of code. You might require hundreds if not thousands of lines to go about solving a problem. Well, it actually isn't. Scikit-Learn is an absolutely beautiful library to work with. It's really easy, it's very intuitive, and at the same time, even if a beginner, a fresher who has absolutely, not a lot of idea about machine learning, if you start working with it, if you dive headfirst right into the syntax to analyze and understand Scikit-Learn, you definitely will have a very good understanding of it at the end of the day. So that is what is our discussion in this course, Scikit-Learn here at Great Learning. Now with that, I know you guys are super excited to get started. Well, what are we waiting for? My name is Anirudh Rao. Let's go.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Now, ladies and gentlemen, to get started with the course, the first thing that we'll always have to discuss is the agenda, of course. So what are we learning on this course, Scikit-Learn and Python? Well, ladies and gentlemen, whenever we're talking about learning a new library, whenever the approach, whenever any approach that you take to learn any library, I believe it has to be very structured. You have to ensure that you are grasping not just what the library can do, but at the same time, how you could probably use the library to maybe devise applications of your own, right? So to now get to all of that, we have to go right back to the fundamentals. We have to go right back to the basics. And as you can probably see on your screen, we're going to start this out by understanding what Scikit-Learn is. Now, I gave you a very brief introduction in my last sentence there, but here we're going to be trying to understand it in an in-depth manner. Now, once you understand what Scikit-Learn is, I bet that you're going to be very excited because, as always, whenever anyone talks about anything machine learning, it really gets me excited. I've been doing this for a lot of years now, and I am sure that you might be feeling the same thing if you're on the other side of this, watching this course right away, right? So, machine learning has always been a domain that is super trending, and it puts out some of the most creative, some of the most efficient and effective solutions out there, right? So we're going to understand about all of that, and this kind of a curiosity will sort of, you'll be asking saying, hey, when can I get started? When can I do this too? So to make sure you guys are set up as well, we're going to have a quick section where I'm going to be guiding you about how you can install Scikit-Learn on your own computer, laptop, whatever it is, and then you can begin working on it as well. Now, after you understand what it is and after we've actually gone on to install it, the next thing that you're going to be curious is, okay, so I know machine learning. I know machine learning involves a lot of algorithms, a lot of variety of learning and all of that. So can I just do everything with Scikit-Learn, or what is it? What are these algorithms that I can use effectively? Or in fact, what are these algorithms that are very popularly used when people use the Scikit-Learn library, right? So we're going to be taking a look at all of that. And once we understand and once we have a very solid foundation there, the next thing that we're going to dive right into is to understanding the applications of Scikit-Learn. Now, the applications of Scikit-Learn are amazing because wherever you can think of machine learning in Python, guess what? You will have a bit of Scikit-Learn, you'll have a bit of the fun machine learning it brings along the way, and at the end of the day, the applications you devise is not just in the IT industry, right? Think about machine learning for a second. Anywhere across the globe, if you can find a problem statement wherein you're gonna have some data, you have some metrics, and you want to make sure things get better, you want to predict what went wrong in the past, or you want to analyze how you could go about predicting your future, any of these requirements, even in the domain of healthcare, right? Again, Scikit-Learn will be used there, right? So applications are endless, and I'm sure you guys will be excited for that section. And after that, once we go about understanding all the bells and whistles, all the fancy stuff that Scikit-Learn provides to us as learners and users and developers, you will then be curious to figure out saying, hey, is it always just advantages with Scikit-Learn, or, are there one or two disadvantages which you must know about? As you can probably read from the heading, there are one or two disadvantages that I want you guys to know about and understand it in detail. So we're going to be discussing that as well. And the last point, as you can see, is practical demonstration in Python. Now, I'm going to be picking up one algorithm. You're going to figure out through the course about what algorithm we're going to be picking up. And I'll show you in a very intuitive way about how easy it is, how fancy, to be honest, how fancy it feels to be working on machine learning. And at the end of the day, you're not writing a lot of code. But what the small amount of code you write has a very, very large impact. That is the magic of Python, and that is only possible because Scikit-Learn is sitting there as a source of that magic, is what I believe, right? So we're going to have a fantastic demonstration where we'll be picking up an actual real life data set to assess and analyze what can be done in a very structured manner. So right from understanding what Scikit-Learn is, right from the absolute basics, all the way to us actually checking out a practical demonstration, not only to learn the practical aspect of things, but to build on top of your theoretical learning, right? That is very important, and we're going to be doing just that, right? So guys, I hope the agenda is clear to all of you all. We're going to be covering all of these points. I'm going to be giving you guys ample amount of examples, and I'm really confident that all of you are going to have a ton of fun learning Scikit-Learn. Super simple, super intuitive. So what are we waiting for? Let's get started. All right, guys. So to come to the first point on the agenda, what is Scikit-Learn? Well, the name seems to be pretty fancy, right? Scikit-Learn. I mean, why is it called Scikit-Learn, or what is it in fact, or how is it associated with Python? I'm sure your head is, you're wondering about a lot of these questions. Let me answer them. First of all, let us understand what it is, right? Scikit-Learn is a library in Python. Now, when I say a library in Python, it basically brings its own set of functions. It brings its own syntax. When I say syntax, it basically brings into its own picture a lot of these helpers, a lot of these things that not only shorten the code but give us immense amount of power and flexibility for a small amount of code, again, to have a large impact, as I previously mentioned, right? Not just Scikit-Learn, Python is known, Python is popular, and I popularly say it in all of my talks and all of my seminars and all of that Python is popular because of the fact that, one, it is written amazingly well. You can write Python beautifully. Syntax is amazing. The second thing that makes Python so great and makes it want everyone around the world to go mad about it is for a fact that it has these libraries which are taking extremely complex tasks and eventually simplifying it to the maximum extent so that you and I can work on it with ease, right? We have an entire community to thank. Of course, the Python community and the Scikit-Learn community, you have to understand, all of these are like open source. So at the end of the day, for you, it is completely free to use. So if you're wondering about starting machine learning in Python, you really don't have to pay anyone anything to actually maybe buy the tools to use it, because Python is free. Scikit-Learn as a library is free. You have multiple IDEs, integrated development environments, that you can use to work with Python for free. Well, at the end of the day, you really don't have to pay a penny to actually get your hands dirty out there, right? So what is it about Scikit-Learn? Scikit-Learn, is, people usually call it the father of machine learning in Python, as in a library, right? It's a way of explaining and understanding the importance of the library. Scikit-Learn as a library itself is considered to be a core library in Python. Now, when I say a core library, what I basically mean is that it has extreme importance, because without the library Scikit-Learn, it would actually make it very, very difficult for us to manually implement machine learning. Now, what I mean, just keep this in your mind until the end of the course, because when I actually practically show you how simple it is to work with this, then you'll realize saying, okay, so if it weren't for this library, that task would have been absolutely horrendous to do, right? So you're going to be understanding all of that firsthand. And again, as I just told you, right, it's a library that is considered super important, not just for machine learning, but at the end of the day, when you think about Python's library, set of libraries that make Python popular, Scikit-Learn is sitting way high up in that chart. And as you can see, it's also say that it's used alongside other beautiful libraries like NumPy, Pandas, or even Matplotlib. We're going to be using all of those libraries in the demo that I just spoke about. But yes, NumPy stands for numerical Python. Pandas is a beautiful library which will give you more data structures to play with. Matplotlib is a beautiful library that will help you with data visualization. So overall, when you're trying to devise a machine learning solution, you're going to be using all of these in conjunction, right? It's not just you using Scikit-Learn. Scikit-Learn gets the machine learning part of it done. But to convey the machine learning part of it to a generic audience, or to even explain it in a fashion that it would be understandable by a wide audience, is where you would require something like Matplotlib. But to make your own machine learning algorithm understand the data, you have to feed it in a very structured manner. For that, you're going to require Pandas. If you're performing any numerical operations, you're going to require NumPy. So in this one sentence that I just told you about, I basically condensed the entire process of handling a machine learning project. And you'll understand that even though Scikit-Learn is the center of the project, it actually fits in a way bigger picture, which is leading to the overall solution, right? That's a really fun part to understand. Now, coming to machine learning is a domain of its own. It's a league of its own. So Scikit-Learn is basically a library. It's like a doorway. It's like a path that almost, I want to say everyone, almost all the learners, take to get towards the domain, right? As you might already understand, right now, wherever in whatever form you're watching this content, there is a bit of machine learning going on in the video player that's maybe using it, or the website that you're watching this on, or whatever it is, right? Right from your phone, your mobile phone, even my watch basically is smart these days. It uses machine learning to continuously analyze and assess what I do so that it can help me better. How fantastic is that, right? Now, if it can help me like that on a personal basis, be it fitness or whatever it is, think about what it can do around the world where we have so much requirement, right? So literally, it has millions of applications and millions of developers who are working day in and day out to make machine learning more accessible to all of you all, first of all. And at the end of the day, it's not just accessibility, it's the way of simplifying a complex domain such as machine learning to make sure you understand it easily, right? Because without Scikit-Learn, again, to reinforce on the same, it would have been very difficult to implement some very simple machine learning solution, because you have to manually just think about the process of machine learning. You're getting your computer to learn a lot of things which it has probably not learned before, it has not seen before, right? Now, you and me, we are cognitive species. We can go about learning really rapidly. When it comes to your computer, when it comes to your laptop, mobile phone, anything digital, in its most fundamental sense, in its most basic sense, the more in depth you dive into your computer, you will understand that you will reach an endpoint where your machine only understands zeros and ones. Everything in your computer's world is just zeros and ones. Now, you would probably be reinforced for a fact that you might think humans are the most intelligent species out there, and now you probably figure out saying why probably you're faster than your computer or something like that, right? But yes, once it becomes that simple, you have to teach your computer to learn, right? You have to make sure it understands what it is seeing. That process in itself is extremely complex, but thanks to the world of statistics, mathematics, and programming, we have basically dumbed down a very complex process to make sure that, even not just researchers, but even freshers, beginners, students, whoever wants to get into the domain can beautifully work with it. And Scikit-Learn, again, is a very, very big reason for all of this, is definitely in my belief as well. Now, whenever you think about machine learning, whenever you think about using a library such as Scikit-Learn for machine learning, your library must be able to do three things with ease, right? With any machine learning algorithm, you're going to require some sort of representation, you're going to require some sort of evaluation, and you're going to require some sort of optimization. Now, what do I mean by this? Let's take a look at representation for a second. Now, Representation basically is talking about the capability of Python, the capability of your working environment to actually you using tools and techniques to make sure that your data is configured in a way wherein your machine learning algorithm can sort of ingest it, can understand it, can work with it, can import it. All of these words that I just said, right? Yes, that is representation. Finding a way to getting your machine learning algorithm to realize that, hey, here's the data, here's how best I can use them. Scikit-Learn works beautifully there. I'm going to show you how. And then talk about evaluation. Evaluation is where, I think is the most human dependent concept, because you will be wondering about a hypothesis you might have in mind. You might think that a solution might work, or you might have a problem statement in mind and a solution. And when you start implementing it and you start making assumptions based on which either your solution will work or not, to support this exact thought in the world of programming, it's you thinking is very different from you writing a program to get your computer to think. Scikit-Learn will help you with respect to evaluation as well. Of course, it will help you with evaluation, because evaluation is the heart of machine learning. After it learns something, you evaluate it to see if it has learned anything or not, right? That's how probably the entire world's education system is. You're probably given a couple of textbooks, a couple of notes or whatever it is, reference material to study. You study all of that. Eventually, you go back to your school, college, university, whatever it is, and you write an examination to showcase that you have learned something. You're proving that you have learned something from your memory, right? You're recalling it. You're showcasing what it is that you have learned. We want our machine learning algorithm to have that capability, and it is very well done. Now, the third thing that the library should help you do is optimization. Now, when I say optimization, think of a situation where you have created a machine learning solution. It is working well maybe to the level of 75% accuracy, right? Now, in the general machine learning world, anything above 80 and all the way to 90-95% is considered to be really, really good accuracy in terms of a machine learning model. Now, it's not just you write a program once, you execute it, the solution is working well, boom, you're done. That never, ever happens in a real world situation. In a real world situation, you'll be the happiest guy when your solution actually starts working towards the goal. But it is also a starting point to make sure you can tune your model to perform better. Think about a very simple example, right? Let's just say you just want to start running. You really like running marathons. You love people whenever they post stories of running like 10 kilometers, 5 kilometers, 15 kilometers and all of that. You want to do it. Day one, you would probably not be able to run 10 kilometers or 15 kilometers at a stretch. Maybe with 6 months of everyday training, you can do it with ease, right? First day, you try it out. Maybe 1 kilometer, you run really well, and then you're tired and you're like, there's no way I can run 10 more. But maybe 6 months later, that starting 1 kilometer becomes like the easiest warm up ever. And you can maybe run 20 more at your best performance ever, right? So what happened over those months? You learned, your muscles are trained better. Everything in your body is working towards you becoming faster and having more endurance. Similarly here, we find ways to ensure we can train machine learning algorithm not just to solve a problem, but we are continuously changing something in the way it learns to make sure that at the end of the day, you have the maximum accuracy possible. So you're tweaking, you're tuning, you're making some changes to get your machine learning algorithm to understand better, and if it understands better, what happens? It gives you a better result that you can take away, right? So it becomes very important in this part of our discussion. Now, coming to the origin of Scikit-Learn, you might have seen machine learning's popularity like rapidly increase all around the world, maybe like in 2012, 2014, right? A couple of years back, less than 10 years back. So it is, whenever again I go to seminars and I address an audience, they always ask me saying, hey, this is a brand new library which beginners might have not heard of. Well, to your surprise, Scikit-Learn is actually over 10 years old. It was basically developed as a summer project, Google Summer of Code project in the year 2007 by this person, a really talented person called David. And originally it was called as Scikit-Learn with a S at the end. And of course, we don't have that S anymore. And what started as a project, a brainstorm of one very talented individual, the project actually went public in the year 2010, after having some sort of research application development. And right since 2010, where are we right now? 21, 22, right? So when you think about it, 10 years back, a library which was made open source, popular, and everyone in the community are not just working to use the library, but there are thousands of developers and millions of intelligent people who are making the library better, as in they're working on the library to make sure you and me can have a more easier way to work with it, right? So Scikit-Learn started out as a research project. It went public. It is open source. It is free. It has millions of collaborators writers who are working to improve. In fact, there are developers right now as you're watching this course, who are working on improving and bringing a better version of Scikit-Learn, right? And all of that is being done for free, mind you. And at the end of the day, Scikit-Learn is used commercially everywhere around the world. So that should really tell you about not just the power of machine learning, but really the brains. And my kudos to all the contributors who have made sure that we have a very good library such as this, right? Now, you might be asking a question saying, wow, this sounds really fancy, but what are some of the things that I should know about when I begin working with Scikit-Learn? Well, I can tell you one important thing. There are definitely certain prerequisites when you have to think about working with Scikit-Learn. And mostly, as I told you at the start of the course itself, it is the dependency with other libraries, because Scikit-Learn fits as a puzzle piece on a very big scale to make sure you get towards a solution. It is not the only puzzle piece, but it is just one among a lot of other things that you're going to require, right? So what are these other things that you're going to require? First of all, we're discussing Python. So you definitely require the understanding of Python syntax. You need to know how Python syntax is written, and you must have the capability to, take something in your head, a thought in your head, and maybe put that down as code. That is going to be a skill that's going to help you a lot in machine learning. Then working with libraries such as NumPy and Pandas and Matplotlib and even SciPy, it stands for Scientific Python. All these libraries that you're seeing on your screen right now, NumPy, SciPy, Pandas, and Matplotlib, they are 90% used together with Scikit-Learn in all of these solutions. So as and when you're learning Scikit-Learn, if you're brand new to Python, brand new to machine learning, watching this course, I highly suggest you spend some time learning Scikit-Learn, at the same time ensuring that you're up to speed with NumPy, SciPy, all the other libraries which are sometimes direct dependencies, right? Now, in the demo that I'm going to be showing you guys, you will realize that it's not just Scikit-Learn that I'm using. For example, the way we ingest data, the way we bring in data, we primarily require Pandas for that. And once you work with it, maybe at the end of the solution, you want to create beautiful looking charts and graphs to showcase the solution. You're going to require Matplotlib for that. Maybe you want to do some array computations and you want to change some values and make sure your data is fed into your model in the right way. You might require a bit of NumPy as well, right? And if you're performing all these statistical operations, data analysis, you're hunting for a lot of insight in your data, you're going to require SciPy. So all in all, a bit of everything is required. But my goal here is to tell you guys, if you do not know, either of these or any of these at this moment of time for this course, it is completely all right, because I promise you, you can follow to the end of it and you can definitely take away a ton of insights from the course, right? Fantastic. Now that we are done with that section, ladies and gentlemen, now we know what Scikit-Learn is, we know its importance, we know its origins, we know the prerequisites, we know what it does, we know that it is a fantastic library, right? So to get you guys started, here is a section where we can discuss about how you guys can install Scikit-Learn. Now, installing Scikit-Learn is very, very simple, because at the end of the day, you never have a hassle to say, oh, my operating system is not supported, right? It is a very common issue that happens. You guys are Mac OS users. There is always a situation where there is an app which is maybe not built or not ready for Mac. In this case, never. Python is widely available in any operating system that you can think of. And if Python is available, there's a very good chance that the libraries that are associated with Python work in multiple operating systems, right? So regardless of the operating system that you actually use, be it Windows, Linux, or Mac OS, I'm sure you guys watching this course are using all three of these, right? So I'll actually help you to install this library in all three of these operating systems. It's really a piece of cake, and we're going to be done with this section, I bet, in the next 5 minutes, right? So firstly, let's just talk about Windows and Linux, because it's very straightforward here. Now, to install a library for Python in Windows or Linux, you have something called as pip. Pip basically stands for, it's a package manager. It stands for pip installs packages, right? So whenever you have to install a package, such as Scikit-Learn, libraries are also called packages. When you have to install it, you basically use the help of another application which is built to install the library of your choice. So it is a standard package manager. It comes built in with almost all the operating systems that we have today. And to actually install the library of Scikit-Learn, you have to run one line of command, pip install Scikit-Learn. As you can probably see here, of course, we have 1 or 2 tabs, which is adding a little bit more of functionality about how it installs. But at the end of the day, if you're on Windows or Linux, all you have to do is open up your command prompts, you open up your terminals, and if you install it via Anaconda or something like that, open up the navigator, open up a command line interface, type in pip install Scikit-Learn, and it works. Now, in Anaconda is basically a distribution that will help you install install all of these at ease. It not only installs Python, but it installs all these libraries which we are actually discussing these days. It'll install it automatically for you. There again, if you, for some reason, if it is not installed and if you want to manually install it, all you have to do is open up the prompt, Anaconda prompt, type in another command, conda install scikit-learn. So we went from pip install scikit-learn all the way to conda install scikit-learn, and this works for Windows. I think most of the version of Windows and most of the Linux flavors, Ubuntu, whatever it is that you guys are using, right? So how simple is this? You have to open a terminal, run a command, done, right? 3-4 steps, you good to go. So it's pretty simple installing it on Windows and Linux. And similarly, if you've been waiting for the section where I say, oh, it's a bit difficult to install on Mac, not really. It's actually as straightforward as us installing it on Windows or Linux, because here again, Mac OS provides you with Homebrew, right? Homebrew is beautiful, and Homebrew is not the only way of how you can install Mac OS. You can actually install Anaconda here as well. Anaconda is supported for Mac OS. You can install Anaconda, through which you can run the same conda command that we discussed, and you are good to go. Now, let's just say you want to install it via Homebrew. Installing via Homebrew is very simple. First of all, you're going to have to install Python itself. Brew install Python will get you to get Python set up on your machine. And after Python is installed, again, it's another simple pip command. Pip install scikit-learn, and boom. Now you have Python set up. Now you have scikit-learn set up, right? So again, just quickly pause in whichever section that you wish. Maybe you're a Windows or a Linux user, pause in those sections. You're a Mac user, pause in this section, get it all set up. And I promise you, it's gonna probably take you 5 maximum of 10 minutes to get everything set up for you guys to start using scikit-learn, right? So as you can take a look at it, it's very, very simple and straightforward. But you might be asking a question saying, okay, so now I installed it, what next? What do I get after I finish the installation? What is scikit-learn giving me after installation, right? Well, first of all, we have to discuss about how it is used completely in the world of machine learning. And in machine learning, supervised learning algorithms are really, really popular, right? Everywhere around the world, but a majority of the solutions are definitely supervised learning algorithms, which are put into use to get the solution done. Scikit-Learn supports many supervised learning algorithms that are out there, and whenever you have to find a way to train your machine learning algorithm better, or find a way to use a certain set of data to make sure that it runs through the same data multiple times and learns better, it's a technique called as cross-validation. And here as well, it's not just one technique that is given to you. You have multiple methodologies that you can use with respect to cross-validation as well. And not just supervised learning algorithm. I'm sure you read the first point and you're like, okay, where is unsupervised learning? Well, of course, it's the core library for machine learning. So you have to have a lot of unsupervised algorithms, and yes, there's a lot of support for that as well. Now, it's not just that you get the functionality of supervised learning algorithms or unsupervised learning algorithms or anything around that. When you have these algorithms, what do you require to start learning and using them? You're going to require data sets, right? So we actually have multiple data sets that come built in with scikit-learn. Think about the Iris data set. Think about the Boston housing data set. All these data sets are, if you're a learner, these are like the pathways that you have to take. And once you've started working with these, right? So whenever a machine learning enthusiast actually comes onto the picture and wants to learn machine learning, I am very, very sure they go through all of these data sets to actually learn the basics of machine learning. And I promise you that you might have heard of it, right? So what scikit-learn people have done is they realize that these are the data sets that are being popularly used by people to learn. So they just built it inside scikit-learn. So if you have to ever use Boston housing dataset, if you use Iris dataset or anything as such, you can actually do two ways. One, you can manually import it if you have the dataset ready in hand. Many cases you might not have the dataset in hand. That's when you quickly actually run a couple of commands in Python and it automatically imports it because the library already has it for you, right? Fantastic. Look at the last point. It says support for feature extraction like bag of words or more. Now, bag of words and all these concepts are super popular in the domain of natural language processing. It has its own library called NLTK, which is super popular for that. But then again, in collaboration with NLTK, in collaboration with natural language processing, you would see that machine learning has a large role there to play, right? So there again, there are multiple support for features which are dependent not just for that subdomain of natural language processing, but it brings together again another piece of the puzzle, which is you using machine learning to solve it. there again support is provided, right? So it's, as I just told you, this is probably one of the best slides to tell you that it is an all-in-all solution for machine learning in Python. And this is everything that you get after running two simple commands. Now think about how easy it must be to actually go about using these libraries, right? Now, coming to a section where we can discuss what are some of the algorithms that are supported, by this library Scikit-Learn, right? As I just told you, since it's the core library, it has to support a ton of these supervised and unsupervised learning algorithms, and it does. So whenever you have any supervised learning tasks which uses regression or classification, it can be worked with ease. Now, when I say regression, think about maybe performing predictions in the future. Think about weather prediction. Weather prediction is a beautiful example of regression. Then if you want an example for classification, think about me giving you a couple of fruits and saying, can you keep all the apples to the left side, oranges to the right side, and maybe keep all the bananas somewhere else? Could you not do that? Yes, if you can do that, you teach your machine how to do that, and that's called classification and supervised learning, right? And then comes unsupervised learning. Of course, unsupervised learning is broken down into two types. It's clustering and association. And Scikit-Learn works really, really good for both of these applications. Now, when you say clustering, you're basically trying to find the common entities. You're trying to find the common characteristics in your data points, group all of these common entities, and eventually try to make assumptions out of it, try to have data-driven decisions out of it, or at the end of the day, use your own clusters to make sure that you are finding maybe better ways of analyzing something, or eventually you are dividing it into clusters to help you further down the line. Either way works really great, right? Clustering is sort of similar to classification, but here the way it works, the way your algorithm itself works is different because it's not supervised, it's unsupervised, right? There's no labels for learning here. And then association. I promise you have used association. Every time you go on to Amazon or any other e-commerce site to actually buy something, let's just say maybe you bought a brand new phone, there's a sale happening, you bought a new phone. As soon as you add the new phone to the cart, have you ever seen that Amazon or any other site, it recommends a lot of other stuff that people have bought. It says, hey, people who have bought the mobile phone also have bought two other things. It's very common. One is a tempered glass, the other one is maybe like a protective case for the phone. We know that majority part of the world, we love putting cases on our phones. In fact, I have a case on my phone right now, putting tempered glasses as well. So Amazon is like sort of telling you, hey, people who have bought that, they've also bought this. So they're making more sales and they're probably making it more convenient for you. You maybe require a tempered glass in a case and they're giving it to you at your fingertips, right? So that is association. It happens in Netflix. Maybe if you watch like 10 continuous crime detective stories, the 11th one Netflix is going to recommend to you is going to be a crime detective story. It's not going to be a comedy TV show they'll recommend to you, right? Because they know what it is that you want to learn or what it is that your tastes are and eventually cater to that. And all of that is happening by making use of machine learning, right? So guys, in terms of support for algorithms, there's amazing support for algorithms. If you want to quickly take a look at the supervised learning algorithms that are supported, of course, there's more algorithms that are supported, but as you can see, you have naive bias, you have decision trees, you have KNNs, K nearest neighbors, support vector machines, random forest algorithm, RFA as it's called, or SVM as support vector machines are called. These are like the really, really popular algorithms. And one side of your thought may be saying, hey, these are like 5 algorithms. How are they solving the entire world's problems? But you'll be surprised to understand how powerful they can get if you provide good quality and quantity of data to perform analysis, right? And in this particular demo, actually, we are going to be taking a look at a KNN implementation. We're going to be understanding how easy it is, how fun it is to work with KNN algorithm. And I'm going to be using the KNN algorithm as a demo in the practical section that I'm going to be showing, right? It's a really interesting demo. Don't worry, before I get into the practical aspect of the demo, at that section, I'm going to make sure that I'm going to explain to you, theoretically how the algorithm works and give you ample amount of examples so you understand it, and then take you guys to the code to help you understand it in the form of code, right? So supervised learning algorithms are great. What about unsupervised algorithms? Well, of course, think about clustering, think about Gaussian mixture models, neural networks, bi-clustering, density estimation. Now, even if you are slightly older into machine learning, even if you're experienced in machine learning, some of these names might be a surprise to you. And that again is one of the ways of the world, right? As I told you, majority of the machine learning applications out there mostly use supervised learning algorithms. And of course, there are ways in which unsupervised learning, you cannot match unsupervised supervised learning in the way it learns. So of course you need support for it, and you're going to require some really good algorithms to make sure that at the end of the day you can use these to have powerful solutions at the end as well, right? So supervised algorithms, we took a look at it. Unsupervised algorithms, we took a look at it. And with this, I think it's the high time we take a look at the applications of Scikit-Learn. So coming to the next section, applications of Scikit-Learn, one of the most fascinating things about the domain of Scikit-Learn you have to understand is that it's extremely popular. When I say extremely popular, I should have probably put it out in caps, because again, right from Netflix to Amazon to healthcare, everyone around you, there's a very good chance the vegetable vendor around you might be using a bit of machine learning to understand what vegetables sell when and how good they sell in which season. There, I just gave you another solution to a problem statement, right? So you can actually, if you're talking about applications, you have to understand that we'll have to generalize a lot of things in this discussion, because at the end of the day, there is a lot that we can go on to discuss, right? So to actually give you a bit of an idea in terms of applications, look at this. We have everything from product development to neuroimaging. Neuroimaging basically talks about how you can, pick up all these MRI scans and CT scans and all of that, right? Pictures of your brain. And probably if you've ever seen a CT scan or an MRI of your brain, to an untrained eye, you have absolutely no clue what's going on. But to a trained eye, to a doctor, to a neurologist, or even to a very highly trained machine learning algorithm, it can make a ton of sense, which probably me and you cannot, because we are not experts, we're not doctors there, right? And then again, medical modeling, financial risk analytics, price predictions, everywhere. Medical modeling is really, really important, because even in the creation of vaccines, right, understanding how you can fight viruses and bacteria, you can have thousands of scenarios be trained by a machine learning algorithm to say what happens when this drug is maybe provided and is maybe pushed onto that virus, pushed onto that bacteria or whatever, right? So there's a ton of things in medical modeling that are using machine learning actively. Now it might come to a surprise to you that I'm highlighting healthcare so much, but please do understand that healthcare has been one of these domains which is extremely important for the humankind, but at the same time, this is a domain that is willing to go beyond anything to explore the power of machine learning, because there's a million things like DNA sequencing and whatnot that takes a ton of time, a ton of efforts, almost inhuman, and that to your machine learning algorithm will be a piece of cake, because at the end of the day, it can constantly do a task maybe 100 times, million times faster than what we could do without getting bogged down, without getting bored, without getting tired, right? So that is what gives power to ML as a whole, and that is what it gives the biggest advantage to us as users. And then look at financial risk analytics. Financial risk analytics, I bet that your banks are using this at the moment, right? So how does your bank know the amount of loan that it should give to someone, right? Of course, there are these scores, CIBIL scores and all of that will tell you how good your credit score is and everything. But at the end of the day, it's a certain risk that is associated with the bank giving out a loan, because they only give you a loan if they're sure that you're going to pay it back, right? They don't want to lose money. But sometimes it so happens that there are defaulters, people who could not pay back. So they're going to use all those situations to learn and understand why people default loans or why people are not able to pay loans. So they use that learning. To understand if they should provide a loan to someone, if they should provide an X amount of loan to someone having a Y amount of salary, right? So it's popularly used, it's being used as we speak right now. And price predictions are absolutely fantastic, be it in the stock market or be it in the vegetable market, because whenever someone tries to predict something that will happen, they're going to require a lot of data from the past and a lot of current data to see, analyze. And prediction is basically you trying to see if any pattern will repeat, you trying to understand if there's any new trends that might be created, or you understanding if there are other outcomes which will affect your current situations, right? Now again, we might see the increase in petrol prices as maybe a spark for the electric vehicle revolution around India, especially right now, right? So maybe one of that is leading to something else, and you want to analyze what is causing what happens if something else happens. All of that is easily possible with the use of Scikit-Learn, with the use of all of these. The applications are endless, right? Again, I have more for you. Think on the lines of weather prediction. Now, this is a very, very fascinating topic wherein you'll be surprised you have machine learning that is so well integrated into your life that you don't know it's there. Open up your mobile phones right now. I'm sure you might have it in your hand anyway. So open it up, be it on whatever phone you have. Say, hey Google, hey Siri, hey Alexa, hey to whichever voice assistant out there, which is first of of all working on the basis of machine learning, open it up and just ask the chatbot about what the weather is like tomorrow. Just say, hey Google, what is the weather like tomorrow morning? It will tell you what the weather is like tomorrow morning, and I am confident that it's going to be very, very, very accurate, right? It's not like it's randomly trying to guess tomorrow's weather. It's not saying, hey, tomorrow it'll rain. No, it's giving you a probability, a percentage. All those are data driven answers that it is giving you, right? And then another really nice application of Scikit-Learn, which I absolutely am a huge fan of, is in emergency services. Now, think about what causes floods, right? An underwater earthquake in the middle of an ocean is where two tectonic plates move and it brings in a lot of water rapidly inside and it pushes all of that out. So when it pushes a ton of water out, you know what happens, right? After an earthquake, it's usually a flood, and that's the entire process of it basically. But what you should know is that it will only take a couple of seconds or a maximum a couple of minutes for a huge flood or a huge wave. Probably the wave is like 10 stories tall, 10 buildings tall. It'll take a couple of minutes to reach from the center of the ocean all the way to the coast or something like that, right? So in those emergency services, we cannot rely on human speed. Of course, we are great at a lot of things, but when it comes to certain things like this, if you have a computer there, it's great. Machine learning algorithms is constantly analyzing and assessing what the seismic activity is like. As soon as it sees a huge earthquake or anything that is alarming, it will automatically go on to do a lot of tasks it's supposed to do. Maybe it'll start raising some gates to ensure that flood water doesn't come in. It starts sounding alarms everywhere around the coast to make sure that people are moving away to safety and all of that, right? It will automatically do it the second it realizes there is a threat. There is no way that it can be done manually that fast, right? Someone is reading a seismograph, they see that something is wrong, they say, oh, okay, this is wrong, now let me call someone else, and that call goes to like 10 other people before starting the alarms. Every second here is a matter of life and death, and when that happens, machine learning will come to your rescue like a million times faster than a human. Maximum respect to all the emergency services personnel out there, because without them, none of this is possible. But just the fact that you can use machine learning as a helper there to make it even fast, I am a huge fan of that, right? And then think about text classification, audio processing, and all of that. You'll be surprised by the amount of feedback you can get just from the reviews of products. If you go to Amazon or any other place where you've seen a lot of reviews about people talking about a product, the owners can actually sit and analyze it in depth. They can get their machine learning algorithm to figure out the sentiment of your customers. Are they happy with your product? Are they sad about your product? Are they angry about your product? Or are they just neutral? Are they just saying that, it's a boring product, right? You can figure each and everything out, and you don't have to sit and read through a 1 lakh, 2 lakh, couple of million reviews to figure that out. Your machine learning algorithm will do it in a couple of seconds to tell you what is going on. That is the magic of machine learning, right? And then, of course, predictive models, as I just told you, be it weather predictions or be it trying to use some sort of regression, trying to analyze, having current data about how that data will forecast something into the future. I don't think not a lot of other domains give you this capability to predict the future, right? Think about cloud computing, think about DevOps, think about all the other beautiful domains that are out there. I rarely find a domain that will give you the capability to predict what happens in the future like how machine learning does, right? That is the magic, that is the essence of machine learning. Well guys, now that we have understood all the applications of Scikit-Learn, I think it's high time we take a look at the advantages and some disadvantages of Scikit-Learn. Now, ladies and gentlemen, as I just told you, right, there are a lot of advantages and there is a small amount of disadvantages which you're supposed to know. So first, let's get away with the advantages, since we are, of course, building a lot of hype in terms of how powerful Scikit-Learn is. The first advantage, in my opinion, is that this library is extremely versatile in helping you solve multiple challenges, problems, not just in the technical domain, not just in the IT world, but be it any other non-technical domain out there. If you're creative and intelligent enough, you will find a way of how machine learning can be used to maybe better an already existing process. Again, I don't see a lot of other domains which are doing that. I don't have anything against the other domains, but this is a fantastic advantage which has to be like a heading when you're discussing advantages, right? And then, as I told you, Scikit-Learn is a library which is backed by a extremely talented community. A lot of talented and hardworking people and open source contributors are making sure that we can work with the library at ease. So it's a huge advantage for us because they put in their own efforts to simplify something really complex for us. And I think that is an advantage because it's these extremely talented and hardworking contributors that is making the library so amazing for us, right? So again, a lot of contribution from their side, and of course a lot of heartfelt thanks from my side and your side, definitely to these guys, right? And then now, I told you, I've been telling you one thing for a while right now. I'm telling you it can already better an existing process. Like it will fit into machine learning will fit into any domain out there. You must be asking a question when I said any or anything and all of that, because at the end of the day, you might say, hey, if there's something which is already existing and working and you suddenly bring machine learning, don't you think it becomes extremely difficult to make your machine learning model work with an already set up and beautifully working infrastructure? Well, with respect to Scikit-Learn, it provides a lot of elaborate API documentation to ensure that you get machine learning to talk really quick to your already existing solution out there, right? So it is not like I have a product, I want to throw that product out and start from the scratch because I cannot use ML with it. There are cases where that might happen, but at the end of the day, in the majority of the cases, you have to understand that many already existing platforms can integrate machine learning into it with ease due to the availability, due to the possibility of these API documentations that are available and made available to us by this beautiful community there, right? So, of course, I had to stop myself with the number of advantages there because I can go on and on and on and tell you about more and more advantages. Let's quickly talk about the disadvantages for a second. Now, in terms of disadvantages, ladies and gentlemen, there are one or two disadvantages, unfortunately. Let's just get into the discussion of them. The first point is Scikit-Learn ML models don't scale very well linearly. See, learning is usually a linear process when it comes to, right? You build up generally and you go on and you go on and you go on and work with that. But small machine learning algorithms are very easily built and worked with Scikit-Learn. But as and when the complexity of your solution goes large, that's where they really don't scale well linearly. You might think that you might require X amount of effort for a small problem, 3x the amount of effort for a large problem. But at the end of the day, it might have come to a fact that it would have probably taken you 10x of the effort to actually get it to be extremely well optimized and extremely working really well. That is not a disadvantage to a majority of the audience, or definitely for you guys as learners, because you'll not be getting into that extreme depths of having a production ready application built right away. But yeah, this is something you have to think about in the long term as well. It's not a bad thing, but it's a small step in the way that will probably get to you at a later stage. The second point is tedious hyperparameter tuning and optimization. As I just told you, it's never a situation where you start writing a machine learning algorithm and boom, you are done with it and you close it. No, the first time your machine learning model gives you a successful output, you're going to be the happiest guy, and you're going to be this person. If you're like me, you're going to be wondering, how can I make it better? How can I make it faster? How can I get its accuracy to be even better? So you will be wondering about what are the different things that you can do to get your algorithm to learn better. In fact, I'm going to be showing you hyperparameter tuning in the demo that we're about to discuss as well. I'll show you practically about how you can find out if your machine learning models can work better and eventually get it to work better, right? And of course, the last point says it needs better model performance reporting capabilities. Yes, I definitely agree with this because I've been using Scikit-Learn for a lot of years right now. And at the end of the day, after you've created your model, after you have had your output at hand, the way that you would report your output, right? There's a lot of things. There's something called classification report. There's an accuracy score. There's a couple of measures of accuracy where you have a matrix that will give you a lot of answers. A lot of ways are there, but is it the best that can be done? I'll say no to that, definitely. I think the community is also working towards that. At the end of the day, we want better ways to denote that our model performance is better. We want better ways to track how the model performance, why the model is behaving the way it does, and we want to do it intuitively, we want to do it easily, and at the end when we're reporting it, we want to make sure that it's not just us doing all the tedious manual tasks, but wherever possible, Scikit-Learn can help us do it better, right? That is at the end of the day the goal of Scikit-Learn, the goal of machine learning here as well. That's what we're after, right? Fantastic, guys. So these are some of the advantages and important disadvantages you definitely need to know about. And with that, I think we can come to the next section, which you guys are really excited for, I can already tell. So guys, coming to the next section, practical demonstration in Python. Now we had a chance to take a look at so many things over the last 45 minutes in terms of theory, right? What does Scikit-Learn? A bit about machine learning. What does Scikit-Learn help us? How is it helping us in terms of machine learning? Why is it so popular? How old is it? What about the community? Is it free? Is it paid? How does it work? what are its popular applications, what are its advantages and disadvantages. We had a chance to take in a ton of valuable information theoretically, but I think it's high time we take a look at understanding maybe one algorithm practically, right? So, as I already told you, I didn't want to keep you guys like completely, in the dark and mysterious until the end. So I told you we're going to be using KNN algorithm. So KNN basically stands for K nearest neighbor algorithm. It's a beautiful algorithm. I am absolutely a huge fan of it and it works really well. First, let me take up one or two examples to explain what the algorithm does, and later let me take you to code to showcase how it works, right? To give you an example of nearest neighbor, basically you understand, if let's just say you are a data point in the algorithm right now, you understand what you would do based on your nearest neighbors, right? As in when I start explaining, it's going to make a lot of sense, but you're basically giving data certain meaning based on everything that is around that. Now, if you know clustering, if you know association, this is where, of course, it's a supervised learning algorithm, but those concepts are very similar to how this algorithm works. Now, I'll give you an example. Maybe let's just say you want to walk to your nearest ice cream store. The ice cream store, let's just say I can see it from my apartment. Maybe it's just 100 meters away. Now, there are a lot of ways I can reach that ice cream shop, right? Some meaningful ways, some meaningless ways. You might laugh at this, but this is a possibility and a probability. First way is I just get down, I walk directly to the ice cream shop, I buy a beautiful ice cream, I come home, done deal. The second way, the way that you will never do, is probably you booking a flight to Delhi from Bangalore, going all the way to Delhi, not doing anything there, flying back from Delhi, going directly to the ice cream store, buying ice cream, coming back to your home. Yeah, I know you're surprised, but that is a possibility as well, right? So you can use one of these two concepts as an explanation to say there are probabilities you have to explore before giving your data some meaning, and that can never be better told than in the KNN algorithm that we are going to be discussing, right? So let's just talk about a very simple classification example in KNN. What I want to do is I want to have a certain data set at hand. I want to have the height and weight of a lot of people, male and female population in our hypothetical data set. And I want to try to predict if based on the height and just the height and the weight. So as I just told you, right, we're just trying to predict the height and the weight of a person regardless of their gender at the moment. And here is the data that we have at hand. Now look at this. Right now I know the male and the female population because I want to just plot it on a chart to show you guys. Here's all the height details. Here's all the weight details of a certain population, right? Let's just consider that all of this is hypothetical at the moment, but you can see a certain pattern when you actually plot it on a graph. Now what I have done is, as you can see, I have 7 details, right? Now this is details of 7 different individuals. Now out of those 7 people, 4 of them are male, 3 of them are female, correct? We know that. But if I plot it on a graph, as you can see, there is a common pattern that's appearing here. You can probably see that the females maybe have slightly lesser height and maybe they weigh slightly less than the male population of data. And you can see all of these pink triangles are females, and you can see all of these green circles or green spheres. These are the male population. Now we have 7 people's worth of data, and what I'm going to do is I'm going to add one more person. Now this person, all I know is that their height is 190, their weight is 100 kilos. That is it. I have no idea if this person is male or if this person is female. So let me plot it on the graph. Now as you can see, this new blue color square, this cute blue color square that I have here is this new population, right? This is the new data that I just plotted there. Now, even if you do not perform machine learning, even if you are not extremely well versed with machine learning, as soon as you look at that blue dot, in which area that it is placed, looking at its nearest neighbors, do you think that that person is a male or that person is a female? I bet at this moment that you guys are saying that's a male. How did you know that that's a male? I've just given you height and weight. What you would have probably done is you would have looked at all the points around that to say, hey, so this person weighs almost similar to weighs and has the same height as the other guys. Good chance the person is a guy. Exactly. This is how your machine learning algorithm is going to learn in KNN as well. Now, what I'm going to do is to give it some sort of meaning while learning. I'm going to say, hey, if you want to understand if you're a male or a female, just look at 3 or 4 people around you to figure out who they are. Now, if I say KNN, K is basically a value there from 1 to infinity. And now I'm going to tell, hey, take a look at the 3 nearest neighbors there. When I say K equal to 3, I'm telling my algorithm, take a look at 3 nearest neighbors around you to see if they're male or female. And based on that, you can learn if you're male or female. And it looks at 3 people around it. It says, hey, everyone here is a male. Good chance even I am a male as well. Now you might say, hey, why did you take k equal to 3? Now take k equal to 5. Even if I take k equal to 5, you can realize that 4 of its nearest neighbors are male people, and one of its nearest entity is a female. Now you might say, oh, now all are not male, one female is also there. What are you going to do? What you're going to do basically is to figure out the majority is what again? Majority of your nearest neighbors are who? Male or female? You have your answer there, right? Now, why we go on to pick up k values to be odd, 3, 5, 7 and all of that is because it works really, really well when we have two classes that we are actually comparing. In this case, two classes, all we have is male, female for our hypothetical example. That is it. We're not considering anything else, right? So for that situation, k odd values work really well. You'll see that they do work well when we go on to actually take a look at practical discussion here, right? Now, I told you about the Boston housing dataset comes built in. Now, I have the dataset at hand, so I can manually go on to import it and start working with it as well. So what we are going to be doing with this dataset is we're going to be using the KNN algorithm to see if it can predict the price of the house in the area somewhere around in Boston, right? That's the dataset we have in hand. So all we are trying to say is get the machine learning algorithm to figure out why your house can be expensive. Now, you know a lot of reasons why your house might be expensive. It depends on the age of the house. It depends on how many people can stay in the house, how many cars you can park in the house, what locality is your house a part of, how far away is your house from the airport, how far away is it from the school, what is the crime rate in your neighborhood, right? Because even if it is the most posh house, if you're building a castle, if it's in a neighborhood which is very shady and very bad, it's not going to be worth a lot of money, right? So what is it that gives the meaning? What is it that has the most oomph, most emphasis when it comes to predicting the price of a house is exactly what we're going to be using KNN to work with this, right? Now, ladies and gentlemen, I'm going to be using Google Colab to showcase the code to you guys. Google Colab is nothing but a Jupyter notebook that is hosted on the Google Cloud platform. You can work with this code in any IDE that you want to use. If you're working with PyCharm, you can work with it. You're using a regular Jupyter notebook, you can work with it. If you're using Colab like me, I love Colab for multiple reasons. You can use that as well, right? So let's quickly go back to Colab and let's get started with the practical discussion. Alright guys, so as you can see, I have Google Colab open. We're going to be understanding Scikit-Learn using a small KNN algorithm demonstration. Now, my goal with this demonstration for you guys is not to show how to write Python code and how to ensure that you get to the result, but my goal is to tell you guys and showcase to you guys that it is really, really, really simple and very powerful to use a machine learning algorithm like KNN and get your solution done using the algorithm, right? So let us actually zoom in so all of you all can see the code. The first piece of code, while working on any sort of solution, my way and the most common way is to basically import all the libraries that you're going to be using. As I told you, NumPy and Pandas we're going to be requiring because as you can see right here, right, this line is talking about us importing our entire housing data set. This uses Pandas and we have multiple use for NumPy, Pandas and all of that, and this is the library we are after. Now, if you're wondering why it does not return Scikit-Learn, well, sklearn, whenever you see it in Python code, understand it's the same as Scikit-Learn. Now, in fact, as soon as I run this demo, it's going to give me a small error. It's going to say, hey, I have no clue where your data set is. You're asking me to execute a data set that I don't know where it is. Now, that is because it's sitting in the Google Cloud platform and the data set is in my laptop. Now, what I have to do is I have to import it into my working environment. I run this piece of code again and boom, it works like magic, right? Now it knows where the data set is. Look at that. So what are we trying to look at it here? Now, every single column here is basically, it's basically a data point associated with respect to house. Every row is a house worth of data. You can see the crime rate in the area where this house is. You can see the age of the house, the amount of tax that has to be paid. You can see like so many different things about a house that will eventually give it a lot of meaning. These are the reasons why a house might cost so much. You and me know this. Our machine learning model might not. So the first step, one thing you have to really be careful about when you're working with machine learning is your data has to be pre-processed really, really well. If you provide bad data, if you provide incorrect data to your machine learning algorithm, it will learn things incorrectly and it will not know what is right or wrong. Now, if I show you a cat and if I tell you guys this is not a cat, this is a dog and it says meow. Have you ever seen a dog which goes meow? Not really. You'll be like, hey, what the hell? But if I show that to my machine learning algorithm, while it is learning and say, hey, this is a cat, if I show you a dog and says it goes meow, machine learning algorithm will not know a difference. It's going to be like, oh, okay, so this is what a cat does, let me learn this. Or this is what a dog does, let me learn this. You know that a cat cannot go bow bow, or you know that a dog cannot go meow, right? So that's the thing, you have to provide high quality and good quantity of data. And in this step that you can see, one line of code, all I'm trying to figure out if there are any NaN values. NaN stands for not a number. Now, for example, when this data set was created, when people were writing the age of the house, it is a number, right? You can see all of these are numbers. None of this is textual data. Someone might have entered a textual data by mistake. Instead of the age of the house, they might have written their name or the house name of the house. That is incorrect, and your machine learning algorithm will flip when it's learning at that point, because it doesn't know why it's different, and your accuracy can fail really, really bad. So with this, we try to figure out if there are any such weird values which are not used, which in fact hurt the algorithm, and we have to remove it. Thankfully, my data set is already clean, so we don't have to do all of that. And we come to the next step, which is really, really important, because here is where we take the entire data set. Now, I showed you first 5 rows. We have hundreds of thousands of rows there. We take that entire data set, we split it into 2 pieces. One piece consists of 70% of data. Now, this is the data that my machine learning algorithm is going to use to learn. Similar to like a textbook in your college. Now, you're going to use that textbook to learn, and later you're going to see new questions or some similar questions asked in the examinations, right? So I'm going to hold 30% of the data away from it. It's never going to see it until the end after it learns. That is when I say, hey, now that you've learned something, let me give you a little examination. Let me give you a little test to see what you've figured out. So on an average, we usually send somewhere around anything above 50%, 50, 60, 70, 80, 90% of data for training. The rest is going to be for testing, right? So all we're doing right now is we are just basically splitting the data into 2 pieces. Now, I said 70% for training. How do you know that? Well, I have a attribute here which says test size equal to 0.3. Well, what I'm saying is take the entire data set, cut 30% out of it, keep it for testing, everything else, which is 70%, goes for training, right? And this is where the magic starts happening. You can see that you were using Scikit-Learn, we're importing the algorithm that we want to use, and basically we are loading that we want to. I'm saying to Python right now, saying, hey, I want to work with KNN, and I want a value of K to be 3. Right? This is what you see in the bracket. Wherever it says 3 here, it basically means that you're using K equal to 3 to work with this machine learning algorithm. I hit play, it executes it, and right now we are telling the Python model that, hey, we are using this algorithm. The next part is model fitting. Model fitting, for all of you all who are new to machine learning, here is where all the magic happens, and this is where you might have a really bright smile on your face right now, is me telling you that, hey guys, this is the step where your machine learning algorithm finishes learning one line of code, one simple line of code, and as soon as I run this, it basically told me that it has used a couple of metrics to go on to learn. Don't worry if you know what any of these means, it's okay at this moment of time. But as soon as I ran that piece of code, my machine learning model has now learned everything it has to know about that data set. Well, great, it has learned something, but I want to figure out what it has learned. So I'm going to pass it the testing data right now instead of the training data. If I provide training data again, it's going to give me 100% result. Think of it like you being in your examination hall, and I come in and say, here's a textbook, write your examination. You don't have to learn anything. You can copy paste, right? To avoid that, here is a genuine examination that I give. The process is called model prediction. And as soon as I run that, now basically the model has also proved its worth to me. But how will I know that the K equal to 3 value that I used here, that is the best value that I can use for the machine learning algorithm? How will I know that there is nothing better than that? This is where hyperparameter comes into the picture. Now, what I am going to be doing is basically I'm going to take the K value from 1 to 50, and I'm going to train the machine learning algorithm 50 different times, and to see where the error rate is the lowest. Wherever the error rate is the lowest, it means that there the model is working really, really well. Now, as soon as I hit play there, look at this. This is all the error rate that's obtained for various values from K1 to K value to be 49. Now, you can see that it's already put out in a sort of a numerical alphabetical order here, ascending order, or not exactly, but you can take a look at this. K equal to 1, there's a very high error of 7.97, 7.1. The lowest that I can see right now is 7.004. This is the lowest error rate, and this is, we are obtaining this error rate when K equal to 4. Well, initially what we did, we thought that K equal to 3 will be the best accuracy for our machine learning algorithm. Now, when we are tweaking and tuning the algorithm, you can see that no, at K equal to 4, you have even better accuracy. This is how you perform this process called hyperparameter tuning. Now, all of this is happening again. Think about it. 1, 2, 3 lines of code. That's it, right? Well, what is the last step then? The last step is for us to tell you guys what is the accuracy of your machine learning model or even the error rate. And as you can see, the error rate when k equal to 3, this was because we use k equal to 3 for training, you can already see that this is the error rate for the machine learning algorithm, right? So let me actually go on to remove all the outputs. I'll clear the outputs. I'm going to zoom out. You might not be able to see any code right now because it's going to become very tiny, but look at this. Here's where we started our demo, and we've done this in what? Everything is done maybe in 25 lines. 25 lines, right from us importing libraries all the way to us actually finding out the error, getting the machine learning algorithm to learn, predict, give us an output that we can use. Did this look like we used thousands of lines? Absolutely not. Did it look like we used hundreds of lines? Absolutely not. We used 25 lines. Yes, this is a very basic demonstration, but at the end of the day, even when you try to implement really complex situations, your Python code is still going to remain same. It's really going to be simple. The way you would implement it would change. That's it, right? So this simplicity that is Scikit-Learn, everything, all these individual lines that I just showed you, all of these are part of Scikit-Learn. Without these, probably for model fitting, if you have to manually do it, maybe you have to write another 100 lines of code just here in that one slot that I've highlighted. Now you replace 100 by 1. This, ladies and gentlemen, as you can see in the demo, is the power of Scikit-Learn. And I'm sure as soon as we complete this demo, as soon as you're done with the demo, you would have figured out on your own that this is a very, very powerful algorithm and a very powerful library, in fact, in Python, right? So guys, with that, we have come to the end of the course. I hope you guys are clear with everything that we have covered in the course, right from understanding what Scikit-Learn is, all the way to deep diving right into the heart of the topic to understand where it is used, why it is so popular, how it works, where it works well, where it does not work so well. I gave you an ample amount of examples. We also discussed the applications of Scikit-Learn. We discussed even the advantages and disadvantages of the library, and those 3 disadvantages, those are really important for you learning right now. Because going ahead, when you guys become experts in the domain, you will come at a point where you know that that's a disadvantage, and then you will be wondering what to do about it, right? So it's good to know so much theoretical aspects of having a wonderful structured way to learning Scikit-Learn, as I probably taught you guys right now. But we also have made sure that we take all the theoretical learning, and I quickly showed you guys a demonstration of using one supervised algorithm called KNN, K nearest neighbors, and I showed how easy it is with the power of Scikit-Learn that you can take a really complex solution and a problem, break it down into really simple terms and solve it in a fantastic way, right? This is again one of the reasons why I fall in love with machine learning, why I fall in love with Scikit-Learn. You can do a lot more for a lot less, and you can't say that about a lot of other domains that are out there, right? So guys, with this, we have come to the end of the course. I hope all of you all were clear with everything we discussed. On that note, my name is Anirudh Rao, and I'll see you on the next one.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.